Okay, we are doing 8M2, lesson 8M5, lesson 2, formal definition of a function. We're going to pick up where we left off yesterday and extend our learning. Let's move over to the screen and let's talk about so the formal definition of a function. We kind of talked about this yesterday, or we did talk about it yesterday, and so I'm just going to go straight to the lesson summary that you have in your notes or your handouts. And a function is a correspondence between a set of numbers called inputs and another set called outputs. And each input corresponds to one and only one output. Now, this again is kind of this gets very wordy, and it's kind of thought of, you can think of functions as, input output machines like this. You put a number in and you always get a number out. And, I'm not going to harp too much on this definition. Instead, I want to go back to these concepts that we've been building on since 8M4, where algebra, geometry, and tables and T-charts are all the same thing, and kind of focus on those rules one more time, because in this lesson, really, you spend almost all of your time in class going over this table or T-chart test to identify whether or not you have a function or not. Okay. Let's remind ourselves really quickly what the y is it's kind of this y is a function of x thing. So if you can write an equation like y, that's our y, and we know the number, the letter or the word is an equal. So if you can write something as y equals, something of x, like maybe that's 2x plus 4, or maybe that's y equals x squared minus 2x plus 9, or y equals the square root of x plus 14, all divided by 3. All of these this is kind of the algebra test says, because I can say y equals something, that tells us we have a function. Effectively on the right side, if I plug in an x, I get out a y. If I plug in an x, I get out a y. Our geometric test, that's our algebraic test. Our geometric test is that vertical line test. It basically says if I have a graph, as long as I can, for any line vertical I draw, I only hit the function line once, then I have, and we went over that in lesson 1. Now, finally, this table or T-chart test. This basically says for duplicate x's for inputs. And really, there's a slight caveat. It says if I have a duplicate input, I must always get the same output. So we'll go over this caveat in a little bit of detail when we hit a certain example. But basically, you want, every time you put in an x, you get only one y. You can get multiple y's. You can have duplicate outputs for given inputs, but for any given input, you can only get one output. We'll show you some examples of this as we go forward. Again, in class, you basically are given lots and lots and lots of T-charts, and you're asked to identify whether or not you have functions. And we'll go over some of those examples here in this lesson. So let's cut forward. So again, there are many examples in the lesson of functions and non-functions, and lots are written in T-charts or tables. So let's look at these 3 examples. Again, I call them T-charts because they have this T, right? You have this big, some people call these tables. They're tables of values. So either way, same thing. Okay, well, let's look at our rule that says no duplicate inputs, or if I have duplicate input, I get the same output. Okay, all right, so let's look at this first one. Here I have, do I have any duplicate inputs? Let's see, I have a 1. There's no more 2s. A 3. Oh, wait, I have 2 3s. So I have duplicate inputs with different outputs. So because I have duplicate input, this is not a function. Not a function. Okay. And so we now go on to B. That's example A. B. We have, one input of 1, no more 1s, no more 3s, no more 4s, and no more 5s. So this is, yes, a function. This is a function. And you say, well, Mr. Lipscomb, I have duplicate outputs. And I say, well, duplicate outputs are okay. Duplicate outputs are okay. The rule is, as long as I put in an input, get out. And this fits the rule. Okay, let's do one more. And now what I want you to do is look closely at this one, because I'm going to tell you that there are duplicate inputs here, but there's something special about these duplicate inputs. I'm going to do a colorization on each input that's the same. Okay, so let's take a closer look at these guys. Look at these guys. And I think what you'll see, and this is really an edge case, you're not going to see this very often, but I just really want to harp on this. These are actually duplicate entries. When I put a 2 and a 9 here and a 2 and a 9, that means when I put in the 2, I get the 9. So I don't have to duplicate. I can just get rid of this entry. 3 and 8 and 3 and 8. These are duplicate entries. So they are saying the same thing. So I can just cross off the duplicate entries. And so now what I have is a function, because I have no duplicate inputs with different outputs. I was trying to trick you, and I'm really trying to draw a distinction here. I don't think there are any examples like this in the book, but if your teacher tries to get clever on you, I want you to know that this is indeed a function. And let me just show you why. We can just graph it really quickly here. So we had 1, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had 1, 10. We had 2, 9. We had 3, 8, and we had 4, 7. But then we came back and we had 3, 8, 2, 9, and 1, 10 again. And so those last 3 were just duplicate entries. And so our function still holds. We don't have 2 outputs for any given input. Input and output. Okay. All right. Well, let's move forward and let's look at some more examples. And I'm going to call this next thing, and this is all you do, the entire lesson. So it's pretty straightforward. So we're going to look at a few problems here, and I want you to solve these. We're going to call this our homework help. And what I want you to do is figure out which of these are functions. So I want you to pause and try with these 4 functions, A, B, C, and D. All right, and we'll just do them all in green. Okay, so now I assume you've paused and tried these. Now look, notice sometimes we can have them be, we can have our input and output be horizontally shown. And sometimes they're vertically shown. So don't let that confuse you. Okay, let's look here. So do I have any duplicate inputs? No. These are all different. So this is indeed a function. And so we will happy cat this guy. Happy cat. Happy cat function. Okay, B. Let's look at this. Do I have any duplicates? Oh, well, let's see. I have 3, 4, 5, 6, 7, 8, 9. Nope. No duplicates. This is a function. Happy cat. All right, let's look over here at C. This is pretty short. Oh, well, I have duplicate inputs. This is, and they have different outputs. So this is not a function. Not. So hopefully you got that. Now let's look over here. Do I have duplicate inputs? Let's see. I have a 1, 2, 3, 4, 5, 6. No duplicate positive numbers. -5, -4, -3. No duplicates. No duplicates. No duplicate inputs. So we have a function. Okay, happy cat. So hopefully this is pretty straightforward. This is what you do. You spend a lot of the class doing, and for some of you this may just seem almost obvious in a very easy lesson, but I just want to make sure that we're comprehensive and giving you lots of good examples. So let's go to one other thing that they're going to ask you to do in the homework, and that is to fill out a chart. So this, instead of saying, is this a function, I'm going to tell you, yes, this is a function, y equals x squared minus 1. Oh, whoops, I gave you the answer. Yes, this is a function because it's like y is. Y is a function of x. So let's say that y is a function of x. Y is, something with x's in it. X squared minus 1. Y is something with x's. Okay? All right. Well, so all we have to do to fill out this chart then is to substitute in x squared minus 1 using our input of -2. -2 is our input. So if we say -2 squared minus 1, that's 4 minus 1, so that's 3. This is -1. We take our input and we put it in. Squared minus 1 is 1 minus 1 equals 0. 0 squared minus 1 is 0 minus 1 is -1. 1 squared minus 1 is 1 minus 1 is 0. And then 2 squared, 0. 2 squared minus 1 is 4 minus 1 is 3. So there's our chart. No duplicate entries. This is definitely a function. And so we can happy cat that. Oops. I'm not sure what's going on here, why my happy cat won't draw. There's my happy cat. There we go. Spinning happy cat. Okay, so this wasn't a terribly long or difficult lesson. We'll we get away with that sometimes. We'll keep moving forward, and next lesson is 8M5 lesson 3. There are 11 lessons in 8M5, and we will get through them, and we'll be on to 8M6 before you know it. happy cat, happy math.